Ashutosh, what key enhancements does the new version of mcube bring, and how does it support agentic AI?
So we have focused on all four building blocks of agentic AI, and our enhancement revolve around these four building blocks. The first one is LLM itself, LLM or reasoning models. So as we all know that every day some or other new enhancement or new innovation in this field is happening. And so for example, few days ago, Llama 4 got released by Meta. And this is again a new age multi-modal LLM, and also capable of reasoning. So any agentic AI application needs a reasoning model as a backbone of it, which can help collaborate between multiple agents. So collaboration is the second building block, and how different agents can collaborate together, how they can coordinate and adapt together. That also is driven from which reasoning model are we using, and how robust these agents individually are. And for that, the third building blocks come into picture, which is the context and contextual information. So for a big business where we are generally working, there are lots of information and different departments, and also the principle on which a particular organization work on. So all these information are generally kept as SOPs and different documents, right? And all those context related information comes to our TCG mcube as different ontologies and knowledge graph. So that enhances the impact of agentic application a lot more stronger. And the fourth one is the governance and compliance feature. So as we all know that agentic application are supposed to work in semi-autonomous or autonomous manner. And when we are giving the control to the machine, lots of guardrails and lots of compliance related things need to be put on. So in TCG mcube, the governance, data governance and AI governance comes out of the box, which again helps the user to configure their own agentic AI application and monitor it in real time.
Yeah, and trustworthy AI, I think, is a really, really important keyword in this context. So how do our agents collaborate within mcube to automate complex workflows?
Right. So in TCG mcube, AI agents generally specialize in different roles, and these are smaller agents which sometimes also are referred as tools. So there will be one agent to bring the data from different sources, like real-time data from IoT sensors, some financial data from RDBMS applications, right? And then there will be another agent or another tool which will be responsible for doing the EDA and creating the AI model. Another tool will be responsible for basically sending out the emails and alerts. And all these tools and agents need to collaborate with each other. And that's where we have our LLM integration framework, where the LLM, the master LLM or the supervisor model, we call it, they help coordinate between all these models. And the modular approach actually help us plug and play different agent for different system, and it also help with reusability. So for everything, we don't have to always create the agent. Lots of agent will come out of the box going forward. And unlike traditional automation, which follow like a rigid workflow, our agents in TCG mcube are context aware. They have the capability of reasoning using the knowledge graph and ontology. And with multi LLM support, plug and play, we can also ensure whether we want a most cost effective model or whether we want most secure model. When we talk about secure model, basically we host LLM inside our premise privately, and so that we are not sending any data and any context outside our organization.
I'd like Ashutosh to share a few examples from your current portfolio of projects that you're working on, so we get a little bit of an idea what the data science team is doing with all this new technology that we're talking about today.
Right. So we are working on agentic AI to solve quite a few problem statements. So I will start with a simple supply chain problem where agentic AI model is coming together, and it is retrieving the data, running some SQL query, and everything is natural language enabled. So you can just ask question, and it is going to train an AI model. It is also going to send an alert or post an order on your behalf without going into and looking into data, and it will also show all the reasoning. So that is one such example. Another example that we are solving is in the field of catalyst discovery. So where we are accelerating and helping the scientists discover the catalyst faster by training fine-tuned LLM model on thousands of research papers, combining it with another agent which is specialized in design of experiment, creating lots of hypotheses, permutation combinations, and then combining ontology to filter out the information and the hypotheses which are not feasible. And the third one that I'm going to talk about is plant reliable AI. So where we are doing combining predictive maintenance, the classical predictive maintenance, I would say, ontologies, generative AI, and agentic framework, everything together to make the plants and industries more reliable when they are running the manufacturing units. And here on this slide, you can see that the data on the left hand side is coming from all different systems that you can think of. A structured data from sensors and process and limbs systems, right? Then comes the semi-structured data, which are like system logs and trouble registers. And not only that, but also PNIDs, PFDs, SOPs, all the unstructured data and document. So utilizing all these data, we have trained the vector embeddings and semantic layer, both kind of agent. And also parallelly, we have created anomaly prediction models on structured data so that it can predict the anomaly before it actually occurs. And not only occurs, but it will predict in time so that you can take some mitigation step to stop the calamity or the interruption in the plant happens actually. And everything is orchestrated by the LLM master agent or reasoning agent, which I was explaining in the first part. So the query goes to the master agent coordinate between different other agents and finally give the answer and recommendation. So the one part is predicting the failure, second part is giving the recommendation on how to troubleshoot that failure, when in the past history this failure has happened, combining it with the cost data to see what it translates into in terms of cost if this interruption happens in the plant. So I'm going to switch to a short demo and show you a short demo on how the interface and the application works. Okay, so in this landing page, you can see a simple schematic of the plant on the left-hand side, and then we have a drop-down where you can select multiple different departments of the plant, and there are multiple components with individual anomaly prediction model being generated here. So between two part of the plant, HP and DP, we are going to look at HP right now, where we can see that in one of the component, there is some anomaly which is occurring. And this component 2S1411C, we are going to look at it. And what it will do automatically, it will generate the alert. And using that alert, we will be able to see whether in the past something similar has happened or not, like PTA water operation and CTA rate down 90%. So now we can see whether similar problem has occurred in the past or not, and everything is being served by different agents. And now on the screen, you see that information which is coming from the historical data. So it combines all of them, like repairing time, downtime, financial loss, productivity loss, and also what was the repairing cost. So you can imagine that all the data like process data, operations data, and financial data are being combined together, and then you are getting this report. And then we go to the mitigation, where we see the licensor recommendation and OEM recommendation, based on which we can troubleshoot the plant and we can mitigate the risk well in time.